The next trio of questions commences with question 16. Which of the following fractions is closest to 5/8? And so what I'm looking to do is to write all three of these fractions, or in fact four of these fractions, over the same common denominator. Now there are a number of ways I can do this. If I have a calculator, I could just multiply 3, 20, 16 and 8 all together to get my common denominator. I can do something a little more interesting. If I look for the lowest common multiple of 3, 20 and 16, I don't need to worry about 8 because 8 times 2 is 16, so 8 is just entirely contained within the factors of 16. So I can write 3 as just 3 times 1, and then I can write 20 as 4 times 5, or 2 times 2 times 5, and 16 as 4 times 4, or 2 times 2 times 2 times 2. And then just imagining my Venn diagram, 3 times 1 is just 3. Then I have 2 times 2 times 5 gives me 20. And then 2 times 2 times 2 times 2 gives me 16. So my lowest common multiple is 2 times 2, 4, times 2 times 2, another 4, so 16, times 3 times 5. So 16 times 15, or 10 times 16 is 160. 5 times 16 is half that, 80. Adding them together is 240. So I can write all of these as over 240. Then I need to know what number I multiply 3 by to get 240, which is 80. 240 divided by 3. So 2 times 80 is 160. 20 multiplies by 12 to get 240. 13 times 12, or 12 times 12 is 144. So 13 times 12 is 156. And then I multiply 16 by 15, as we established earlier, to get 240. So 11 times 15, or 10 times 15 is 150, so 165. And then I need to compare those to 5/8. In order to get 240, I multiply 8 by 30. So 5 times 30 is 150 over 240, and therefore 13 over 20 is closest to 5/8. As I say, with a calculator you can circumvent a lot of that, but I thought it important to demonstrate the overall process. Question 17. The Richmond Park gamekeeper wanted to know how many deer were in the park. He caught 90 of them and put a small tag around the hoof of each of them. He then let the deer go back into the park. The next week the gamekeeper caught 70 deer. 10 of the deer had a tag around one of their hooves. Using this information, what estimate did the gamekeeper make for how many deer were in the park? Well, assuming here that those samples are both representative of the whole population, we know that here 1/7 of the population has been tagged, and therefore those 90 that he caught and tagged must be 1/7 of the total population. So to find the total population, I'm doing 90 multiplied by 7, which is 630. Write down any one assumption he made. I'm not convinced that MathsWatch is all that good at marking these questions for you, so I do apologise if you've been unfairly treated. I tried to avoid them as much as possible. Basically, the assumption being made here is that the two populations are representative. So that could be, for example, that none of the tags have fallen off, or it could be that the population hasn't changed. So, for example, the same number of deer are in the park both weeks, or no deer have left the park, or no extra deer have been added to the park. And in the GCSE exam, the mark scheme will say any sensible answer. And basically it is your population representative in each case? Question 18. A toy car is placed on a floor. It moves in a straight line starting from rest, so I know that at 0 seconds its velocity is 0. It travels with a constant acceleration for 3 seconds, reaching a velocity of 4 metres per second. So at 3 seconds, it's reached a velocity of 4 metres per second. Constant acceleration means the gradient of my line, change in velocity divided by change in time, is constant, and therefore a straight line. So that's just the idea that constant acceleration means constant rate of change of velocity, constant gradient. So I've sorted that out. It then slows down with constant deceleration of 0.5 metres per second squared for 4 seconds before hitting a wall and stopping. So I know that acceleration is change in velocity over change in time. So my change in velocity is my acceleration, or in this case deceleration, so minus 0.5 times my time 4, so I lose 2 meters per second. So after 4 seconds, that's to 7 seconds, I'm down from 4 meters per second to 2 meters per second. Once again, constant deceleration means my gradient is constant, so a straight line. And that's part A, draw a velocity time graph, sorted. Part B, what is the total distance travelled by the toy car? Speed is equal to distance over time, or velocity is equal to displacement over time. So displacement is velocity times time, which is the area under my graph. So I can do that in a number of ways, but probably easiest is just to split into 2 right angle triangles and a rectangle. So the area of this right angle triangle is a half times 4 times 3, which is 6 meters. Looking at my units, meters divided by seconds times seconds is meters. Then I have a half times 2 times 4, which is 4 meters. And then I have 4 times 2, which is 8 meters. So in total, the distance travelled is 6 plus 4, 10, plus 8, 18 meters. And that seems sensible for a toy car in 7 seconds, moving relatively quickly. And that's the next three questions sorted.